Density is a physical property that describes the amount of mass contained in a given volume of a substance. It is defined as the mass of an object divided by its volume. The formula for density is density equals mass, volume. The metric unit for density is kilogram per cubic meter, but it can also be expressed in gram per cc or other equivalent units depending on the context. The density of a substance is typically influenced by its composition and temperature. Different materials have different densities, with some being denser, having a higher mass per unit volume, and others being less dense, having a lower mass per unit volume. The density of water is approximately 1,000 kg per cubic meter at standard temperature and pressure, which is defined as 0 degrees Celsius or 32 degrees Fahrenheit and 1 atmosphere of pressure. In gram per cc, the density of water is approximately 1 gram per cc. It is important to note that the density of water can vary slightly with temperature and pressure changes. For example, at higher temperatures, water expands and becomes less dense, while at lower temperatures, it contracts and becomes denser. The density of seawater is higher than that of pure water due to the presence of dissolved salts and other minerals. The average density of seawater at the surface is approximately 1025 kg per cubic meter or 1.025 grams per cc. However, it's important to note that the density of seawater is not a constant value and can change with variations in temperature and salinity. Cold seawater or water with higher salinity tends to have a higher density, while warm seawater or water with lower salinity has a lower density. This value can vary depending on factors such as temperature, salinity, and pressure. Seawater density increases with higher salinity, lower temperatures, and increased pressure. In general, the deeper you go in the ocean, the higher the density of seawater becomes due to the increasing pressure and decreasing temperature. Salinity, which refers to the concentration of dissolved salts, also affects the density of seawater. Regions with higher salinity tend to have denser seawater. To obtain more precise values of seawater density, comprehensive oceanographic data and specialized equations that account for variations in temperature, salinity, and pressure are used. These values are typically available from oceanographic institutions and databases. What is the relationship between density and draft survey activities to determine cargo quantity? As we know, in calculating the quantity of cargo using the draft survey method, there is a step to correct the observed density value with the density value of the waters where the ship is built. The density value of the waters where the ship is built is usually 1.025 kilograms per liter. This value is not fixed depending on the calculation database from the architect. So it is very important for surveyors, sailors, and people related to this to know what is density and how to measure the density of a water. How do you measure the density of water? The most common way is to use a hydrometer. In the context of a draft survey, a hydrometer can be used to determine the density correction factor for accurate calculations. The density correction factor is applied to account for the variation in water density due to factors such as temperature and salinity. A hydrometer is a device consisting of a weighted glass tube with a graduated scale. It is designed to measure the specific gravity or density of a liquid. In a draft survey, a hydrometer can be used to measure the density of the water at the survey location. To determine the density correction, the surveyor takes a water sample from the survey location and measures its density using the hydrometer. The hydrometer reading is then compared to a standard reference table or formula to obtain the density correction factor. This factor is then applied to adjust the observed draft readings for variations in water density. By incorporating the density correction factor, the draft survey calculations become more accurate, as they account for the specific water density at the survey location. This ensures that the cargo quantity calculations are more precise and reliable. It's important for draft surveyors to use calibrated and accurate hydrometers and follow standardized procedures for obtaining density corrections to maintain the integrity of the survey results. What is the formula for getting this density correction value in the context of a draft survey? As previously explained, it is very important to use a calibrated hydrometer to get maximum data accuracy. How to use the corrected value on the hydrometer. So, after watching this video, we hope you can understand what density is and the importance of density correction in calculations to determine the quantity of cargo using the draft survey method and the importance of using a calibrated hydrometer for accurate results. See you in the next video.